There it is, Ryzen AI Halo. AMD built Strix Halo, the chipset on which this is based, as a workstation APU. We first saw it something like 18 months ago. We crazy internet randos looked at it then, and we immediately saw the 128 gigs of memory, and we said, cool, what if we use that to do crimes against model size? AMD was really early here, and that was even before NVIDIA launched their 128 gig DGX Spark. And weirdly, Strix Halo worked. It definitely worked for AMD. I mean, 48 gig coding models at roughly 60 tokens per second, a 92 gig mixture of experts model, roughly 20 tokens per second, local, quiet, on a desk, less than 200 watts. So why is this product coming out now? Well, there were some problems with the software side of things. It was never the silicon. The problem was always everything around it. ROCm versions and ROCm modifications for Strix Halo, memory allocation myths, BIOS settings, container bugs, Vulkan escape hatches, and enough GitHub issues to make you reconsider your life choices, at least the life choices that led to working on AI stuff in the first place. But this is the story. This is the pin in the corkboard, if you will, for AMD having hit both software and hardware milestones. It's not just a known good Strix Halo system with Linux, in my case, also available with Windows. Playbooks and firmware updates piped right into the Linux way. LM Studio support, that's what I'm running here. Comfy UI, which is in the background, that's not a problem. This is the standard bearer for what comes next. It points toward Gorgon Halo, a larger unified memory machine, 192 gigs coming with that update in Q3. But also the rest of the Strix Halo ecosystem is going to be pulled up behind this, which is great. Fixed playbooks, firmware updates, clarified memory behavior, known good ROCm stacks, and known good Vulkan stacks, known good playbooks. And that's going to elevate everything from Minis Forum and Framework Desktop and GMK Tech and all the other versions of Strix Halo out there. And that is what we can rally around. This is the real milestone. It's not just a flagship box, but a reference point the whole platform can finally rally around. A Halo's Halo product, if you will. This is AMD's Ryzen AI Halo developer platform. And yes, the name is funny because it's Strix Halo, and it's already a Halo, and this is already a Halo product. This is a Halo product. Somewhere, there's a product manager that's glowing. The hardware is familiar. Ryzen AI Max 395 plus 16 Zen 5 cores, Radeon 8060S graphics, 128 gigs of unified LPDDR5X, a compact, attractive chassis, available either with Linux or Windows. The price, $4,000. That price is maybe the first problem, but we need to chat about it. But more to the point, Framework, Minis Forum, GMK Tech, B-Link, Corsair, HP, and others have already shipped Strix Halo-based systems, and some are much cheaper. Some are much more expandable. I've got a 25 gig Ethernet card in here. The Framework Desktop also has a PCIe slot, but in their case, it's not accessible. But if you put the motherboard in a different case, it's totally okay. GMK Tech gives you an Oculink slot. You've got options. Almost all of these have multiple M.2 slots, except for the one from AMD. Let's get a 2280 at least. So, I mean, I'll take it. But yeah, it's a lot of fun. Oh, and the fact that I've got a 25 gig dual port Intel E810 NIC in the Minis Forum, I think that does change the conversation a little bit around clustering. I mean, if you look at the networking here, you've just got the one Realtek 10 gig NIC. And that's all that is in our AI Halo system. But you can still cluster it. You can still build some clustering stuff. In fact, I think you should check out Donato's video on this. He has been building a Strix Halo cluster. He's the Strix Halo toolboxes guy, and cluster like this out of that. Yeah, it works. It was a latency problem the whole time. But back to this. Why does this exist? What is AMD doing here? Because it's not remotely about Strix Halo, at least not this late in the product cycle, I think. This is AMD planting a flag and paving the way for Gorgon Halo, the next generation product that rhymes with this one. Probably just a chip swap and memory swap as well. And that's right around the corner. Q3, so AMD says. So we have at the back, if we take a look at the rear I/O, USB-C power from the 240 watt power brick, 10 gigabit Ethernet thanks to our Realtek chipset, 3 other USB-C ports. One is recommended for DisplayPort alt mode, and 2 others that support alt mode and USB-C connectivity. There is no other high-speed networking, Oculink, or even a second M.2 internally. It's just the one. At least I'm pretty sure there's not, because I took it apart. I mean, we can all look together. Taking it apart is easy and repeatable, though. There are screws underneath the magnetic feet. There's also a Kensington lock port, so that's appropriate for university labs and that sort of thing, where maybe you might have one of these and it would walk off. But physically, this is one of the most Lilliputian options for Strix Halo. Now, the obvious comparison that I've alluded to, NVIDIA DGX Spark. Both are small local AI workstations. Both have 128 gigs of unified memory. Both target inference and developer workflows. Both claim support for very large models under the right quantization and optimization parameters. Right now, on Newegg, you can still buy Spark for about $4,000 to $4,500. DGX Spark has the stronger platform story where NVIDIA, it tends to always come out ahead. I mean, CUDA, DGX OS, container workflows, and the scale-out networking. The scale-out networking really is something special. The networking difference matters, I think. Spark's ConnectX path is a real pro feature and not a spec sheet decoration. If you are trying to stitch two boxes together, NVIDIA starts ahead. And the skills that you gain from dealing with NCCL, NCCL, that's NVIDIA's communication primitives library, the skills from that will transfer to multi-million-dollar AI clusters. So you learn and you do stuff. AMD's counterpunch is flexibility, and at least historically, price. This is x86. It runs Linux. It has also always run Windows, whereas NVIDIA is planning Windows support for their stuff, but it's not here yet. And AMD uses open-ish tooling. It does not require you to buy into the CUDA worldview, and for many inference workloads, especially token generation, Strix Halo is basically the same performance as DGX Spark. And that's because both systems are ultimately gated by the unified memory bandwidth. And it's basically the same. It's very similar between the two platforms. The short version for view, like anybody that doesn't have the attention span, Spark is cleaner for NVIDIA's approach, but the Ryzen AI Halo is more flexible workstation. Spark has the better networking story. Halo has the better, I could just use this like a PC story. Oh, and I'm not sleeping on networking over USB 4. That is an option here. You can use those USB-C ports to connect to other machines, kind of like a Mac. But I want RDMA to be a part of that story when we talk about it, because RDMA is not here yet for that. You can do it over USB 4, Thunderbolt, and it's on the order of 20-ish gigabit, give or take. But yeah, I mean, I don't know. NVIDIA made some weird choices with Spark 2. Like, they didn't use a 2280 M.2. 2280, everything on this table, 2280, which is the only sane option. Why would they do that unless they just wanted to put a crappy, it's like, oh, we can't just buy a 2280. So, yeah. Because this is a pre-existing platform, Strix Halo, and because it's from AMD, I got to go off on a tangent for a second. There's a lot of bad information online about Strix Halo, especially around memory and how the memory works in a unified platform. People say there's a difference between what NVIDIA is doing with ARM and Strix Halo. That is not true. They treat it like as if the machine has two physical memory pools. It does not. On Linux, the important mechanism that the GPU uses to map through the shared memory pool is through GTT and TTM. For most AI workloads, you do not need to reserve 96 or 112 gigabytes of memory permanently for the GPU. When I was doing gaming reviews on laptops that were based on Strix Halo, really killer machines like the ROG Flow Z13 and the HP G1A, I showed games like Clar Obscur running at a high frame rate, but with only 512 megabytes of reserved VRAM. Except in some really legacy software scenarios, it's often the case that for AI workloads, this is the better option as well. Keep the BIOS reserved GPU memory very small, and then let the Linux kernel driver expose the large shared pool dynamically. The old mental model for this and why it shows up wrong a lot of the time, I think comes from Windows. On Windows, the split is more visible and more annoying. AMD's variable graphics memory exists because software still asks things like, how much VRAM do we have? And it'll freak out if it encounters 512 megabytes. But most software has been updated to be aware of the thing that exists with unified memory platforms. This is a major problem for NVIDIA too, with their planned RTX Spark, the stuff that we saw at Computex just a few weeks ago. Because, Windows. And so, of course, I checked how they were handling Windows on the machines that I saw there. And guess what? Windows got fixed. And the unified memory fix there benefits AMD too. That's sort of the funny part here. The work that Microsoft has done, apparently fast-tracked because now NVIDIA needs it as well. ends up greatly helping AMD's Windows Strix Halo experience. I'm not got anything Windows related in this video, probably a follow-up video if I can get my hands on the software image, but Strix Halo in a nutshell, it is not a 96 gig GPU. It's a 128 gig unified machine that can address a large pool of memory. And when the OS and the driver stack are configured correctly, I've got up to 112 gigabytes of memory on this platform for the GPU without any issues or headaches or any really like special hackery that I had to do. It just works. So the people that complain about memory allocation or like freezing or hanging or something like that, they're not facing problems with the memory allocation. It's probably something else because it is a well-executed unified platform. Sometimes an LM Studio, just toggling off try mmap is all you need to do. That's the thing that people get hung up on sometimes, but I digress. So now AMD has this, Playbooks. This is the thing that I literally told Anush at Advancing AI. AMD needs a website of known good recipes that are part of your CI/CD process. Every time AMD pushes an update, every run through, every little thing, your CI/CD system kicks off and runs through all of these playbooks to make sure that it all works. AMD should have had this on launch day. The reason they did not is probably simple. Strix Halo was not originally positioned as an AI developer appliance. These are useful playbooks for the individual as well, because they run, like, these are common things that you would want to do. The community realized early on that Strix Halo was going to be good, too good at inference to ignore. The playbooks turn, I spent all weekend trying to weed out if it runs better with ROCm or Vulkan, into open the developer center, find the thing that's close to what you want to do, and run that. And out of the box, shipped with this thing, over 380 gigs of stuff. It's got Lemonade and WebUI and VS Code. Well, you got to download VS Code, AMD Sync, workflows. There's a whole bunch of stuff on here that is ready to go out of the box in terms of both models and configuration. The Lemonade server from AMD, as I mentioned, and Comfy UI. This is amazing. This is AMD putting the most effort I have ever seen from AMD into making the client side experience smooth. And that is the real review. It's not really this box. It's the software. It's the mindset, because all of this executed properly benefits all of this. That's what I meant when I said it's going to bring up everything. Yes, you could run a 122 billion parameter class model on this Strix Halo. That is an amazing sentence to be able to utter in 2026. But I do not think the best daily driver layout is necessarily one enormous model eating the whole machine. The better version of this platform is probably a competent 27 to 30 billion parameter coding or reasoning model as kind of the main brain, with a constellation of smaller models around it. Maybe one for routing, maybe one for summarization, maybe one for retrieval cleanup. Retrieval augmented generation is a fun thing to explore. Maybe one for vision or OCR, fast drafting. Maybe one for tool use verification. Smaller models do prompt processing faster, respond sooner, and leave room for deep context and parallel work, and make some of the slower running models a little bit more tolerable. How big a model can you cram into memory is not really that awesome. It's how many useful local intelligences can you keep alive at once, I think. Okay, so real world performance. Yes, you can run a 120 billion parameter model on this, but that's not really the point. And actually, a dense 120 billion parameter model would be difficult. Understand, if you're just getting into this, the difference between mixture of experts and a dense model. And I'll use Quen as an example. There's a 35 billion parameter Quen model, and there's a 27 billion parameter Quen model. The 27 billion parameter Quen model on this is going to run 12 to 16 to 20 tokens per second, depending on some parameters. And that's at a Q8. It's 8 bits per weight quantization. You can run 4 and 6 bit, but I think with Quen, you start to lose some of the fidelity of the model when you're much below Q8. It's actually natively 16 bit. So a 27 billion parameter dense model would be double that. You need like 48 gigs. And yes, you can run that on this, but you're going to be in a relatively low token throughput situation. Mixture of experts, it's like Quen 35B, it's a 35 billion parameter model, but that A3B means that only 3 billion parameters are active at once. Those kinds of models, mixture of experts models, are great for systems like this that are memory bandwidth constrained, because only 3 billion parameters are active at any one time. And the quality output between the 35 billion and 27 billion parameter models, like how good they are, like how good they are at doing tasks, is pretty similar. The setup that I have here is with Turnstone. And I'm doing something really interesting. Remember the 4 GPU R9700 system that I'm running? That also has 128 gigs of memory across 4 GPUs. That's in the basement. This system is controlling it. This is an orchestrator. And this is toward that whole agentic thing that everybody talks about. So Turnstone is a piece of software that's available on GitHub, and it's open source. And it is amazing. And I need to do another video on it because it's kind of like Hermes or OpenClaw, but it's, enterprise mindset. It does some things a little differently. And again, separate conversation. But Turnstone running on this with a Qwen 35 billion parameter model is smart enough to be a supervisor. Now, that is nowhere near as smart as the best models that you can get on, OpenRouter or OpenAI or Anthropic. Those are frontier models. But you can connect those models to Turnstone through an API. But you can also use this to minimize the amount of tokens that you spend in the cloud. You see, this is an orchestrator. It doesn't have to be the smartest model for you to get utility out of it. And with an A35B type model with multi-token prediction, that's another thing that you probably want to try to do. It means that you try to get more than one token per prediction, and the acceptance rate on that is typically 60, 70, 80%. That'll improve your throughput. In addition to the whole only 3 billion parameters active, a lot of words to say that you can get 30, 40, 50, 60 tokens per second per session and 3-4 sessions running in parallel. And so like with Turnstone, when you run an orchestrator like this and you give it a task, it can split up the task into 4 or 5 pieces and work on them simultaneously. And each piece that it's working on doesn't have to run with the same model. So like you don't have to be limited to Qwen. It's like, the 35 billion parameter, that's going to fit in, 48 gigs of VRAM. What do I do with the rest of the VRAM? You can run more models. You can run a model that's really good at OCR, a really small model. Gemma from Google is also really good. They have some small models that are 3-4 billion parameters that are fantastic. One of the reasons that Qwen is so amazing is because they publish papers and make it really easy for you to do your own fine tuning. And so even though those models are smaller, they're also larger, and there are smaller Qwen models that you can fine tune on a platform like this. Now, it'll take a couple of weeks, like it'll run for a long time, but you can set that up on a platform like this, and then you have customized the model and trained it on your data. The difference between retrieval augmented generation and, fine tuning is that you have a lot of data that doesn't really change, and you want the model to be read in on the data that you wanted to have it access to. Fine tuning is probably worth it. But retrieval augmented generation is you sort of front load a lot of data into the model with the requests. And so retrieval augmented generation, you have like a vector database or something like that. You take information and you do some processing to it. And at runtime, it is injected into the model in a different way than fine tuning does, sort of, kind of. And so with every request, the model has the context of the documents that you've added. And so that's why I say retrieval augmented generation. It's generating tokens augmented by the fact that it retrieved the contents of the documents in a vector format or something like that. They're not the raw format. You got to process the documents that you're feeding for RAG. Whereas fine tuning, you run this process on the model is modified. And then when you run the model, it has information about the documents that you gave it for the fine tuning process. Both of those things are achievable on this platform because of good documentation that goes along with the model. And Qwen has been a standout among all of the options available in terms of how well it is documented. And this platform is fast enough for you to do those kinds of things, both academically and in an actually useful kind of way. Now, for like software development and things like that, there's a lot of really low level, bog standard, like janitorial type things. Like, I need help organizing this Git repo. I need help writing a unit test. I need help, doing this evaluation. I need you to run through the unit tests or help me figure out why this one is failing. You don't need a frontier model for a lot of those kinds of really low level tasks. And you can run that on here with Turnstone or any other harness that you want. And that works fine. And it runs acceptably fast, in my opinion. The utility of these kinds of models and the state of the art, like how the software has moved the hardware over the years, is a big part of the story here. The software that's available now in mid to late 2026 is light years ahead of where we were a year ago, even though the hardware hasn't really changed a year ago. So it does feel like a new platform. And it is really nice to see that level of development and speed. So the big thing with agentic and benchmarking in a platform like this is don't think of AI as monolithic. Don't sit down. It's like, we're going to one-shot a Tetris clone. If I ask this thing to do a Pac-Man clone or something like that, it's going to spawn a bunch of tasks. It's going to put a plan together, and then there's going to be a bunch of agents that are running, maybe on the same model, maybe on different models, in order to complete the tasks. And that kind of thing can function as a benchmark, but know that because of the memory bandwidth here, the performance for most models is on par with NVIDIA's DGX Spark now in 2026. Now, I mentioned some off-label use cases. All about the off-label use cases. Thunderbolt. It's not really Thunderbolt, it's USB 4. 2 of the 3 ports are capable of USB 4, 20 gigabit. So here you can see we've got our external Razer X2 Thunderbolt 5 dock connected, and it's got a big honking GPU in it, and we've got 20 gigabit both ways, so 40 gigabit interface. And we can see that our GPU came up properly. And this is a big deal because when Strix Halo first launched, they didn't really plan on having GPUs. Like, even the folks like me that took our framework desktop, this is one of the first Strix Halo machines that I got, and extended out the X4 slot. This X4 slot can only provide 25 watts. You need 75 watts for a GPU. So you got to do some Herculean things to even get a GPU plugged into that PCIe slot, which is just 4 lanes. It wouldn't post because the BIOS wasn't plumbed to do that. It's a AMD firmware team. Like, it's like they're so isolated. They gotta come into the fold. We gotta all work with the AMD firmware team. And so this is a fix. This is a fix since launch, which is great. It's great to see this. And this worked well with some other different configurations, even running 2 of these things. Also for Thunderbolt networking. Now, you can do Thunderbolt networking, and it is relatively low latency, but you really need RDMA, not RDNA, RDMA, Remote Direct Memory Access. Remote Direct Memory Access would theoretically give us 20 gigabit, very low latency connection, not through a Realtek interface. It's not as good as something that's 100, 200 gigabit, but it'll get the job done. I really think that AMD could have put something based on Polara or maybe a little FPGA in there. I think one of a competitive differentiation thing that AMD could have done is give you another M.2 and maybe with like an FPGA that would give you maybe something you could experiment with in terms of, we can just do our own custom fabric. Maybe even direct PCIe connection, because the PCIe, it's not really that much of a lift to provide a software layer to do a direct PCIe to PCIe connection through, Oculink or something like that, with a little bit of custom glue. But that's not really the thing for this video. But this is really exciting that you have an interface. You can also kind of build an unholy machine here because, I've got 48 gigs of really high-speed GPU VRAM plus 128 gigs for mixture of experts type models. This is unholy. And we've done videos on that in the past where you're running a high-performance GPU that has 16, 32, 48, 96 gigs of memory plus 128 gigs of much slower LP, our DDR5 here. But that lets you run much larger mixture of experts models and also lets you run smaller mixture of experts models much faster. And also a bunch of, agents or a bunch of models running simultaneously on a platform like this. Eminently doable. Oh, and AMD has found a way to make the NPU useful in this, because remember, it's designed as a laptop. There's an NPU. You can run multi-model scenarios and use the NPU. Things like speech recognition. And some of the larger models will also work on the NPU at shallow context with reasonable speed. There's some amazing benchmarks of FastFlow LM in exactly this scenario. You run Llama 3.2 1 billion at over 50 tokens a second below an 8K context. And the prefill speed with that is over 2,000 tokens per second. So if you've got a pretty awesome, carefully planned setup, you can do a lot with that. Now, before AMD had a polished story, Strix Halo made their own. Donato that I mentioned, he made the Strix Halo toolboxes. Those are the obvious example. Containerized environments for LLMs, image generation, fine-tuning, ROCm, Vulkan, Llama.cpp. He's top of mind right now because we're working on something together, and I think it'll be a lot of fun. But there are many other unsung heroes in the community for AMD building amazing things with Strix Halo. Reddit sentiment tracks this perfectly. The happy users are running Lemonade and llama.cpp, LM Studio, and models like Qwen or Gamma, Stepfront, Light LLM also, Open Web UI, coding agents. I'm running Quopus, which is a lot of fun. Multiple models at once. They're creating a local box that is quiet, low power, private, always available, and works well. The frustrated users are usually stuck on one of three things: ROCm edge cases, image generation performance, maybe memory configuration confusion. Things like the try mmap setting in LM Studio has tripped up a lot of folks in our community, especially if they, read an older how-to and it's like, oh, let's create 64 gigs for the GPU and 64 gigs for the host. And then LM Studio needs slightly more than 64 gigs and it trips over the try memory map because it's trying to load it twice. It's trying to load it to system memory and then copy it over to GPU memory. But that's not how that should work at all. If you're going to go off script and use ROCm, I would recommend the ROC version of the ROCm if you're not going to use one of Donato's toolboxes. Some people report excellent LLM performance, but then miserable diffusion behavior, and then they spend a lot of time troubleshooting that. Windows users in particular get stuck because of the whole shared memory thing, and Windows reports things in a way that makes shared memory, but that's going to be fixed with the updated version of Windows that's coming soon. Oh, I also did a clone. I tried to clone this image onto our other Strix Halo machines like GMK Tech Minis Forum, also the Minis Forum NAS that I reviewed recently. Check that out. And our Framework desktop. Now, our Framework desktop wouldn't boot because it ran into a systemd issue that is a systemd bug. But generally, most things work better than I expected. The Framework desktop tripping over the systemd bug, you don't have to use systemd. You can use something else. Mostly you don't have to, though. I was sort of expecting that if AMD is going to say, here is the formula, you can do this, that they might also provide some hints around configuring distro and kernel versions, because that can also be a source of chaos and headache. But no, it's not ready yet. When I move this over, it depends on the UUIDs of the partition not changing. So when I got an update and it applied the update, it assumed that the partition UUIDs had not changed, which was not true. There is one concerning issue on GitHub. Well, there's a couple, but 6182 is a generalized Strix Halo thing. Users are hitting non-recoverable HSA memory faults when trying to load PyTorch or HIP models on some Strix Halo machines. The issue report goes pretty deep. Multiple kernels, multiple ROCm versions, different BIOS UMA settings, and AMD's official ROCm PyTorch container, and also the ROC builds, kernel parameters, and it's the same class of crash happening. This is also why the community deserves credit. Things like Donato's Strix Halo toolboxes and the Reddit Discord forum crowd got a lot of this working before AMD's official story caught up. We've all proved that the platform was worth caring about. Now, that ROCm bug doesn't happen on this platform, and it doesn't happen on the machines that I have as configured, or configured really similarly to the way that the AI Halo is. But there are obviously a lot of people that it is affecting, even though the software is the same. It may be like our Framework desktop, where it is a systemd bug, but the systemd bug is triggered by something in the BIOS. And it is fixed in a newer version of systemd. So it's just not yet on the platform here. So what's not to like? Nothing to do with Strix AI Halo, but the discrete playbooks, I can't help but notice on the developer website, it says coming soon. I mean, that's just too on brand for AMD. That's kind of the microcosm. AMD gets the hardware right, and it's amazing. The community's excited, and then the software story arrives late, and also with footnotes. By the time AMD has polished the appliance, the ecosystem already has, other options. It's like, oh, we'll just get it working with Vulkan, or oh, something else will get put together, and then the community builds a tool chain, and then before you know it, AMD has sort of working to do something that is parallel to, but maybe not quite in line with what the community is already doing. But also, Gorgon Halo is really close. So if you're a value buyer, maybe buying smart is waiting. I mean, Gorgon Halo is going to be faster memory and up to 192 gigabytes of unified memory for bigger models and local AI. Now, that might matter, but I think the performance to VRAM ratio is already a bit out of whack at 128 gigabytes with these crazy inflated prices. I mean, I'll take more memory if I can get it, but I mean, the bang for buck buyer may not want to spend $4,000 on a late cycle Strix Halo box when cheaper Strix Halo systems exist. And the Gorgon Halo refresh is visible on the horizon. Q3 is just right around the corner. But I think AMD sort of expects that. I don't think they really expect a lot of people to buy this particular aluminum box. Aluminium. AMD can ship a more cohesive local AI ecosystem experience. That's the story here. And you can be up and running on any of these platforms with LM Studio pretty much immediately and have a lot of fun, and it's amazing. And this website, the software model, and AMD making cohesive efforts to let you have this kind of fun and productivity with your Strix Halo box, that's what we need more of. This product is a Halo product in another sense, not because AMD expects to sell millions. As I said, I really don't think they do, but because it lights the path. It is literally a pipe cleaner for the next generation of local AI machines on the software and hardware side, I guess is what I'm saying. Developer workflows and working out the developer workflows are very, very important. And it's probably a good idea that that's not, the untapped masses of the internet. I think for where we are in 2026, it reminds me of what I've read about the early 1980s. Back then, everybody had heard of computers, but few people could imagine what having one at home would enable. And a lot of the same societal concerns now rhyme with what people were worried about back then. I mean, a lot of people were concerned if the computer would replace their job in the 1980s. Sounds a lot like today. And these boxes are a glimpse of the alternative. Powerful local models, private data, predictable costs, no token tax, and no tools that live elsewhere. The tool lives on your desk. I think the future gets much more interesting when the machine that is thinking with you is yours and lives on your desk. And I think it opens up a lot of possibilities, which I'm very excited about for the future. I'm Wendell, this is Level 1. It is fantastic to see this kind of a launch. If I missed anything, or you want to chat or run some tests or build some things or generate some images, let me know. Hit me up at the forum. I'm signing out, and I'll see you there. Eating cereal while driving a car. I'll take it.